All right, so up next is Ted Neward.
All right. So they asked me to do a lightning talk on Monday, and I said, sure, I'm happy to do a lightning talk. What do you want me to do? And they said, well, you've got this session that we see on your list, Introduction to .NET Bytecode, CIL. And I said, okay, and how long is a lightning talk? And they said 5 minutes. I can't even finish the prologue to the ECMA specification in 5 minutes. You want me to go over the entirety of that specification in 5 minutes? They said no, because if you actually do the full talk, we're worried you're going to make everybody's brain melt. I'm like, oh, okay, all right, fine. So what I'm going to do is I'm just going to introduce you to the concepts of, and trust that those of you who are interested will go pursue it further. Now, most of us know what this is, right? I mean, granted, the F-sharpers in the room, they won't be able to recognize this, right? But the rest of us, we know what that is, right? The question is, what does that turn into? Remember, IL is the intermediate bytecode representation that the CLR actually executes. Well, to be fair, they don't execute it, they do a just-in-time compile, but then Mono goes ahead and execute. Okay, we'll just say it executes, right? And there's all kinds of interesting things about bytecode, but the most relevant issue that most .NET developers need to face is the fact that bytecode is what your source code turns into. So if you ever looked at the yield return statement and wondered, how exactly does that work? How many of you know how it works? Show of hands. Yeah, like 3 or 4, maybe 5 hands, right? The rest of you are like, oh, no, I just use it. It's just there. I mean, why? Okay, so is this actually a better or worse performance curve than, for example, working with a collection or something similar? You won't know unless you can drill one level below the level at which you're at. And IL is actually one of the simplest assembly language you'll ever see in your life. So I'm just going to do a Control-Shift-B here to print up my little hello world thing here. And then over here, we're going to fire up a utility, comes free, out of the box, with every installation of Visual Studio called Ildasm. Okay? And unfortunately, Ildasm has forgotten my font settings. So view, set fonts, tree view, and we'll kick this sucker up to, say, 24. And what we're looking at is the assembly in its sort of native tree structure. What we see, first of all, is hello world.exe up there at the top. The assembly, every assembly always comes with a manifest. You can drill into that and look at some of your declarations, for example, the module name, et cetera, et cetera. We can also see hello world there with this little interstate shield symbol next to it. That's actually the namespace declaration. Then we can see inside of it one node, hello world.program. Well, that's the full formal name of the hello world thing that I just built. And you can see .class private auto ANSI before field init. We can see .ctour, that's the special name for the constructor. We can see main down here. And main, looking back at Visual Studio here for a second, it's pretty boring, right? So let's go look at the bytecode that makes that thing up. Whoops, and again, Ildasm, not remembering fonts, making me grumpy. 24. You gonna be able to do that there, Ildasm? Yeah. All right. So what we see here is initially what looks like gobbledygook, right? Because most assembly languages, unless you know how to read them, look like gobbledygook. But here we see dot method. That indicates that this is a method as opposed to a field or a property of some other form. We can see static void main. We can see a bunch of things that we recognize from C# because the C# language is actually a pretty faithful representation of what we see in the ECMA specification. We can see dot entry point. That's a directive that says specifically this is the entry point to this assembly. This is where we begin. It has nothing to do with the name main. Main is only important to C#. C# puts that directive in. And if you wanted to program in IL assembler, by the way, we can dump this out to a text file, modify it if you'd like, or if you really want to prove your programming chops, you can write IL assembler by hand. That's if you really have something to prove to your coworkers, all right? But notice that here we can see a bunch of local references here. Actually, that looks different than what I had in my... This is the Hello World application, right? Well, all right. Doesn't matter too much because what we're looking at here, this is actually some sample code that I cut down, but I guess for whatever reason it didn't get saved. So we can see, first of all, the first instruction is a no-op. That means the same thing in every assembly language. You can see load stir, hello world. The IL environment actually has an understanding of objects. So what it's doing here is it's pushing a reference to that constant string onto the execution stack. Everything works off of an execution stack. Operations like load stir push things onto the stack. Operations like call will pop things off of the stack. We can see call virt, that invokes a virtual method. The try block here says we are actually going to set up an exception handler. We can see some references down here at the bottom. You can see the end of the method, et cetera, et cetera, et cetera. And I told you I wasn't going to be able to teach you all of IL in 5 minutes. That's all I got for right now. But all you have to do is 2 things in order to start studying all of what I've just shown you. Number 1, you got to download the ECMA specification. That is the official reference on IL. Number 2, fire up Ildasm, look at some code that you've written, look at the generated output, work through the execution stack. Everything else is just details. Peace.